All right. Are we good? All right, we're gonna get started. So, wait. So, like I said, my name is Dan. Thank you for coming. There's my email. In case you need to send me any questions about my notes or whatever. I'm on co-op, and I do absolutely nothing at work, so I'll answer all your questions. So let's just get started. Our first topic is going to be Laplace. So I'm just going to go first over the definition of Laplace, our little integral, in case they throw us a piecewise function. So we have our Laplace transform. And our definition of Laplace is the Laplace of our function f of t equals the integral from 0 to infinity of e to the negative st times f of t dt. So in a problem like this, it'll usually give you like a piecewise function or some function and say use the definition of Laplace to find this L of f of t or L of y. So super simple integrals. This is how we get all of our table here. We just plugged it into there and people made a table so it's easier for us. So I'm just going to go. So here we're given a piecewise function f of t equals e to the 5t from 0 to pi, and it equals 2 at t is greater than and equal to pi. So here, right, a simple integral, we know from calculus how to separate an integral using a piecewise function. So we just have our function from 0 to pi, because that's our first piecewise. E to the 5t, which is our function, times e to the negative st dt, plus our integral from pi to infinity of 2 e to the negative st dt. So keep in mind, right, this negative st or this negative s and this negative s are both just, it's in terms of dt, so we can treat it as a constant in our integral, right? So when we integrate this, we're going to have e to the t times 5 minus s, right? So I'm going to by the du is 5 minus s in the denominator from 0 to pi, plus, same thing here. So this is our constant from our du part. And this is from pi to infinity. Any questions about how I integrated this? All right. So I'm just going to put this up here. And we're just going to plug in our bounds. So we have e to the pi 5 minus s over 5 minus s. And then when we plug, this is just going to be 1. So minus 1. And then plus 2. I just brought that 2 out in front. And then we're going to, when we plug in infinity, this is going to be e to the negative infinity. So that's going to come down to our denominator and be 2, or going to be e to the infinity, which is going to be a really big number in our denominator. So that's going to lead us to just 0. And then minus e to the negative pi s over negative s, because we just plugged in pi. And then when we simplify, we just get e to the pi times 5 minus s over 5 minus s minus 1 plus these negatives cancel plus 2e to the negative pi s over s, and that is our final answer. Oh, sorry, 5 minus s. Super easy. Any questions? Everyone sees it? All right, so that's just going to be our class. So it'll probably look something like this, like a piecewise function, and we're just going to have to take the integral. So when it says use the definition of Laplace, then that's when we use the integral. All right? So, all right, up here. Definition of Laplace, we're using this equation. Cool. All right. Now we're just going to move on to regular solving an ordinary differential equation using Laplace. So there's a few steps that we're going to need to know the Laplace and the properties of Laplace. So that's like our y equals, wrote this down also. So Laplace of f just equals the Laplace of f. And then the Laplace of f s equals s Laplace f of s minus f of 0. And the Laplace of our f double prime in terms of s equals s squared L. I'm running out of space. S. Don't worry about copying this. You're going to get this on the formula sheet. Yeah, you're getting a formula sheet, right? You better. All right, so this will be the least of what's going to be on your formula sheet. And this is really everything you're going to need to know. So don't worry about copying this. The only thing that's important is that you just recognize different forms that looks something like this or something like this. You know it's going to be like a cosine or a sine. If we see that's like 1 over s minus 1 squared, we know it's times the e to the at. So just like familiarizing ourselves with all these, for our inverse Laplace, it'll be able to recognize everything and just like move really quick is super important. So do not memorize them, but definitely familiarize yourself and like understand everything, obviously. All right. So for our ordinary differential equation using Laplace, so this is going to be our steps. All right, so 1, we're going to take the Laplace transform of both sides using our tables. So we're using these tables to just take the Laplace and plug everything in. 2, we're going to plug in our initial conditions. So right here, if we have our a second derivative or a first derivative, we're going to have f of 0 here at sf of 0 or at f prime of 0. So we're going to plug in our initial values that are given. 3, we're going to use some algebra to solve for our Laplace of y, which is the same thing that's equal to like our Laplace of f of x. Or just like they also sometimes do f of s. That means all the same thing. Then 4, we're going to take the inverse, almost forgot that. Take inverse Laplace of both sides. And that'll give us the final answer. So since we'll have a Laplace of y on one side. So if we take the inverse Laplace, then the inverse Laplace and the Laplace are just going to cancel out and give us y. Whatever it gives us on the right side is going to be the answer to our differential equation. All right, simple. Other things to note, they might just ask you for this. So read the problem and understand what they're telling you. If they say find f of s or just like take the Laplace transform of this function, then we're just going to stop right here. We're only going to go here if they say like find the solution to the ordinary differential equation or like find y function. All right? So if they ask you to find, just take the Laplace transform, just take the Laplace transform, and don't waste your time. More. All right. I can erase this now, hopefully. All right. All right. So this is a pretty simple, just like first order ordinary differential equation. So they might give you something with a y double prime, and it's just going to be the same, except you're just going to have to use this transform as well. But for this problem, I just wanted to show how to do the steps and how to get through everything so everyone understands how to do the steps, and then you'll just have to know if they give you y double prime, now you also have to add this term in. And then also, so they give us the initial condition, y at 0 equals 0. So the first thing we're going to do is take the Laplace transform of both sides. So bam, I'll write it out like this. Minus the Laplace transform of y equals, and I'm just going to bring this 5 out. We can just like treat it like we do an integral with our constants. 5 Laplace transform of t e to the 2t. All right, so now we're going to look at our table. Let me get out of the way. So the Laplace transform of y prime is going to be this right here. So in terms of s, it's going to be s times the Laplace transform of y minus, I'm just going to call this y at 0, f is 0, same thing. Then minus this right here. We have our 5 out in front. And then we're going to use this transform right here. So this transform is saying, I know this is like kind of misleading. We take the Laplace transform of, so our f of t is this t right here. So n factorial over s to the n plus 1. And this is just saying that instead of s, we're plugging in s minus a. So t is going to be to the power of 1. E to the and a is going to be to the power plus 1. 1 plus 1 is 2. So this is our Laplace transform. Is anyone confused how I got this? Beautiful. Going. Y at 0 equals 0. 0. Easy. Next step, solve for y. So we have two L equals 5. Right? Up here, oh. Now, so we solve, we didn't solve for it yet, so we're going to divide by that minus 1. So Laplace transform of y equals 5 over s minus 2 squared times s minus 1. All right, we did step 3. Now we're on to step 4. So we're going to inverse Laplace. So inverse Laplace of the Laplace of y, which is just going to be y, equals the inverse Laplace of 5 over s minus 2 squared s minus 1. Where our numbers come into play. So we're going to need to separate. We can get in some form of the Laplace table. S minus 2 squared and a s minus 1. Or something. We got issue?
Yeah.
Battery dead?
It's not being nice.
Oh, good. No problem. Awesome. Good? All right, thank you. Okay. Cool, thank you. All right. Bring it back. Let's get back to some DiffyQ. All right, so we're going to have set this partial fraction, or this fraction up s minus 2 squared s minus 1. So we're going to set this up. When we have an s minus a to a power, we're going to have a over s minus a squared plus b over s minus a, and then plus c s minus 1. So these two terms, this a and this b term, come from this s minus 2 squared, this term, s minus 1. Super simple. So there's two ways to go about this. You can either set up a system of equations, or you can just find values of s that would give you 0, and then it'll cancel out. So I'm going to do it. I'm going to find values of s that set terms equal to 0. I want to like check the work otherwise. If you want to do it that way, what we're going to do is we're just going to multiply by s minus 2 squared, s minus. So here times s minus 2 squared, s minus 1. And I'm just going to rewrite. We're going to get 5 equals a times s minus 1 plus b s minus 2 s minus 1 plus c s minus 2 squared. So I just multiply through. For our a term, the s minus 2 squared gets canceled out, so we get left with the s minus 1. For the b term, 1 s minus 2 gets canceled out, so we're left with b s minus 2 s minus 1. Canceled out, so we're left with c times 2 squared. I'm just going to multiply minus a plus b s squared minus 3 bs plus 2b plus cs. Oh wait, no, I don't want to do that. Sorry. Erasing this. You could do it that way. I need to do it the other way. So we're gonna have. I'm gonna use s's. So we can s equals going to be 0, and we're going to be left with c. This term's going to be 0, and this term's going to be 0. We're going to be left. And then I just use s equals 0 because the only unknown I'll have is b. Just solve for b. All right. 0, 0, c, s minus 1 minus 2 squared, which is just 1, c equals 5. Easy. Then s equals 2. This term is 0, this term is 0. We have a times 2 minus 1 equals 5. So a also equals 5. And then we're going to plug in 0. So we get 5 equals 5 times 0 minus 1 plus b 0 minus 2, 0 minus 1 plus c 0 minus 2 squared. So if we just put all this together, 5 equals negative 5 plus negative 2 times negative 1 is positive 2 plus 2b times 5. 5 plus 5 minus 20 is negative 10. Negative 10 divided by 2 is negative 5. B equals negative 5. Does everyone see how I got that? Right, so again, we're just looking here. What numbers can give us 0 in our terms? And that's going to cancel out some of our variables. So here, right, we're left with one variable if we plug in 1, and one variable to solve. So we set s equal to, you can set s equal to any number as long as you have a and c to get b. Does everyone have this? Can I bring one? All right. I'm going to erase this because we're almost done. All right. So you have a equals c equals 5, and b equals -5. So we had our a. So it was 5 over s minus 2 squared minus 5 over s minus 2. So we're going to take the inverse Laplace of, right? But now we have it broken up into and figure out what to do. So we have 5 over s minus 2 squared. So this is similar to what we have right here, right? We have, it's the same term, actually, 5 over s minus 2 squared. That's going to be our 5t e to the 2t. So this is our a term. A is here, s minus a. This is n plus 1. So if we have n plus 1 equals 2, then n equals 1. So our answer on top of this t is going to be 1. Then we have minus 5 times e to the 2t. That's simple, s minus a. 1 over s minus a. A is 2. Form, right? Plus f e to the t. And a is just 1 there. So yeah, this is our final solution. So that's how you solve and using Laplace. Any questions? We straight? Looks. All right. Do you need to see this again? All right. I'm erasing. Yeah. I did the Laplace transform of this, the inverse Laplace, I mean. So if we're using this here. So this function is saying that we have e to the at, the f of t, gives us the so here our is t to the n. So t to the n t, so right, the Laplace of this is going to be 5 over s. Since it's s minus 2, we know that we multiply by e to the 2. Tell me if it doesn't. I'll try to. Before we keep going on to unit step, thank you. I just wanted to throw just like a few partial fraction rules up so you guys can like just with partial might like trip you up a little bit. Property of a fraction is if you have a minus b over c. So you might have something in the numerator that's like a s plus 4 over s or something. I don't know. So just like break it up. Your transfer. Thing, right, is if in the last problem we had c over s minus a squared. So that's going to be our a over s minus a squared plus over s minus a. Simple. They might throw at you. So if you have c over s squared plus b, where you can't factor as plus b over s squared plus b. They might try to throw. This is like a super simple one. So if they ask for the Laplace inverse of s over s squared plus 4s plus 8, right? So this term, obviously, we can't do anything with this, but we can do completing the square. So we could say this is s and then that equals for s plus 2 squared plus 4. And then this is going to be similar to we can see the s plus 2. So we know that there's going to our term here, this s plus 2 has to match what's on top. So then we're going to take the Laplace transform of s plus 2 over s plus 2 squared plus 4 2 over s plus 2 squared plus 4. Here we added 2 to make sure that agreed with this. And then we subtracted 2 because we can't just like add 2 onto an equation because then it's not the same equation. So we have to subtract what we add on. Something that you might get seen thrown at you, so just know like you got to look for completing the square. If they give you some polynomial that can't be factorable, so that'll take time, and you'll really put examples more on my notes so you guys look through them and see what else. So yeah. Yeah, this is a 2. This is also 2. All right. gonna bring it back, everyone. Thank you. We're gonna keep going. So this is our form of unit step, right? So this is how we write a piecewise function in terms of unit step. So this A1 is just gonna be where our function starts. So our start point, and this A squared is just gonna be our end point.
That's A squared?
This is A sub 2. So this is A1 and A2. So just our first A and our second A. I'll show you in my problem. You guys see that? So this is just our start point. So this is just our variable. This is our second variable. So can I erase this now? I'm gonna erase it. All right. So we're just going to take a piecewise function and put it in unit step form. So you have f of t equals 3 minus t from 0 to 2, and then it equals 1 from t is greater than or equal to 2. So we're just going to put this function in a unit step so that we can take the Laplace transform later on. So we have f of t. So this is where I'm going to use this step. So we have f of t equals, equals our first function, which is 3 minus t. And then it starts at 0. So the 0 is our a1 minus ut minus 2. So it starts at 0, and then it ends at 2. Then we're going to have our second function, which is just 1. So plus f of t, which is 1, times u, and then it starts at t minus 2, and then it just goes to infinity, so we can just cut it off there. So this is our unit step. And then we can keep going. We can multiply everything out and factor some things out as well. So if we keep going, we have 3 minus t u to the t minus 0 minus 3 minus t u to the t minus of t minus 2 plus u to the t minus 2. So now we can factor out this right here and this right here. We can just treat this as a constant or just like a term that we can factor out. This u to the t minus 0 can also just is the same as u to t, which is also just the same as 1. So we can just write this 3 minus t. And then, so here, if we distribute this, negative, so plus minus plus, we have negative 3 plus t plus 1. So that's going to be plus t minus 2. So negative 3 plus 1 is negative 2. U to the t minus 2. Does that make sense to everyone? I factored that out. Yeah? I see a few confused faces. Right, so I just multiplied by negative 1 here, so it's negative 3 plus t, and then here it's plus 1, so there's a 1 here, so negative 3 plus 1 is negative 2, and then we have a positive t here. Alright? I'll give you guys a few more seconds to copy. This term is just 1, so I factored out 1. I did negative 3 plus 1 is negative 2. Yeah. All right, everyone. I didn't go over this one more time, right? So here, so I distributed 3 minus t to this right here, so I multiplied this through, right? So now I have a negative 1 times 3 minus t, which gives us a positive, in parentheses, negative 3 plus t. Are we there? You got to that point? And then we have this plus 1 u to the t minus 2. So I just treated this whole thing as a term. So this whole u to the t minus 1. So here I factored out a 1. And here I factored out a negative 3 plus 1. So then I was left with negative 3 plus t plus 1, which gives me t minus 2. So negative 3 plus 1 is negative 2. And I just put the t in front. Cool? Yes.
What happens to the first part with the t minus 0?
This? So this is just, so u to the t minus 0 is the same as just u to the t, which is just the same as 1. So you could keep it like this, but it doesn't matter. Cool? Can I erase this bad guy? Alright, let's keep moving. We're going to move on. Before we move on, I'm just going to shamelessly plug Movember. So for those of you that don't know, do you have something to say before I move on? I'll get to it. All right, word. So yeah, so me and some of my fraternity brothers are participating in Movember. So it's just a men's health organization where we grow mustaches and like look super cool on campus. So I'm just gonna plug like my my fundraising page in the email that I send out. So it's about men's health and just like men's mental health and prostate cancer and testicular cancer awareness. So check out my Mo page, it's pretty cool. If you follow me on Instagram, I'm gonna be posting a lot of stuff about my mustache. So do that also. Okay, now on to this is the really fun stuff. So, you guys are going to be so excited for this moment. Yeah, I'm ready. I'm just ready. All right. Okay. So this is the problem statement. So this is going to be given to us on our formula sheet. So it's right here at the bottom. So we have our function that's in terms of f to the t minus a with a matching u to the t minus a equals e to the negative as. So that's, this term, the negative as, times the Laplace of just whatever the Laplace of f of t is. So not the Laplace of f of t minus a, just the Laplace transform of f of t. So this is the equation that they're giving us, and this is just asking us to find the Laplace transform using unit step. So I'm going to do the same thing that I did in the last problem. So I have my f of t equals 1/3 t to the 6 minus t, and then we have u of t minus 0 starts at 0, minus u to the t minus 3 ends at 3, plus our function 3 times u starts at u to the t minus 3 and ends at infinity, so I can just close it off. So right, so starts at 0, ends at 3, starts at 3, ends at infinity. So I'm going to do the same thing I did in the last problem, so this is just going to be like a little bit of heavy algebra, so just stick with me. If you lose your footing, then let me know. So I'm going to multiply this 1/3 t into this parentheses. At the same time, I'm going to do it into this bracket. So let's see how fun this is going to be. So it's going to be 1/3 t times 6 is 2t minus 1/3 t times t squared is 1/3. Oh, let me rewrite that. I'm already lost. It is 1/3 t squared. I'm just going to put that in parentheses. And then we're multiplying that by u to the t minus 0, which I'm just going to simplify as u to the t because it's minus 0, so it doesn't really matter. Then I'm also, since this is in a bracket, I'm also multiplying this whole term by this u to the t minus 3. So minus 2t minus 1/3 t squared times u to the t minus 3. And then just plus this term, plus 3 u to the t minus 3. All right. Does anyone have questions on how I got from step 1 to step 2? All right, so we're going to keep going. The main thing we're going to do here is the same thing, same step a few of you got confused before. So factoring out this term and this term. So I'm going to have a negative 2t plus 1/3 t squared plus 3. And then we're just going to have this term be the same. So, all right. So we're going to have, actually before that, okay, we're not going to do that yet. All right, so if we look at our transform, we have f to the t minus a times u to t minus a, right? So we have to get our equation in that form for us to be able to do the Laplace transform. So if we look at our first term right here, we have a t term, a t squared term, and a t minus 0. So all these terms are the same. Do you see that? So we have t, t, and t. Here we have t, t squared, and t minus 3. So those don't match, so we're going to make a match. And then here we have no t's, so we're good. So I'm just going to write this again. Equals 2t minus 1/3 t squared ut minus, so the way we're going to do this is we're just going to insert a t minus 3. So now we have our f of t minus a, but you know we can't just add or subtract 3 to an equation. We also have to add 3 to cancel it out. Oh, so that's 2, so add 3. And then we're going to do the same thing with this t squared. So we're going to do t minus 3 squared, or t minus 3 plus 3 squared, u to the t minus 3. And like I said before, there's no t in this term, so we can just keep that the same. So plus 3 u to the t minus 3. So are there any questions about how I plugged in this negative 3 and the plus 3 and this negative 3 and this plus 3? Yeah.
Did you like put together first and do that, or does it matter like how you do it?
Yeah, like you could put that 3 in there, it would be fine. So we're going to keep going. So this equals, I'm just going to write, so that's the same, so I don't have to write it again. I'm going to distribute this 2, so minus 2 t minus 3 plus 6. So I multiplied this 2 and the 3 and brought it out of the parentheses. Minus 1/3. And then this is going to be really tricky. So I'm going to FOIL this out. So it's going to be 3 times t minus 3 squared. That's not right. Where's my eraser? Here it is. A new eraser. Alright. So I'm going to FOIL this. So it's going to be t minus 3 squared. So t minus 3 squared plus, it's going to be 3 times t minus 3 plus 3 times t minus 3. So 6 t minus 3 plus 9 u to the t minus 3 plus 3 u to the t minus 3. I assume there might be some questions about how I FOILed this. Should I go over that? Okay. All right. So I have that term, right? So t minus 3 plus 3 squared. So that's the same term as I have up there, right? So this equals t minus 3 plus 3 times t minus 3 plus 3. So you have this first term, t minus 3 squared, plus this term, 3 times t minus 3, plus this 3 times t minus 3, plus 3 times 3, which is 9. Does this look better? So we're just FOILing it, except we have a t minus 3 term instead of just like a regular t. And then I just combined it like terms, so this is t minus 3 squared plus 6 t minus 3 plus 9. Does that make sense? I know it's like a little confusing, but it's just like some hard algebra. Yeah.
Would we be fine to swap out t minus 3 for a different variable just to make it easier when we're factoring it all out, and then swap it back in later?
If that's easier for you, then go for it. But you'll just have to remember that like this is gonna have to be the same as the inside variable.
Okay.
So it would just be like t minus a plus 2a times t minus a plus a squared t minus a plus t plus a squared. Yeah, that's what I said. All right. Can I cover this? Can I go back to this? All right. So we're going to keep going because we're not done. So this equals that term again minus. All right, so here we're going to do some more magic, right? So we have a term here. 2, this term is like terms with with this term, right? So we have 2 minus 6, which is minus 4. T.
Wait, isn't it?
Wait, yeah, so there's a negative here. I'm leaving this negative out.
Yeah, but isn't that a plus in front?
So, where?
The 2's positive, isn't it?
This 2 is positive.
Yeah.
This 6 is negative because of this.
Yeah.
So, a positive times a negative is a negative.
But you have to multiply by negative 1/3.
Would they cancel each
So
other
would it be?
out?
Oh, yeah. No, you're right. You're right. Yeah, so, alright, so we have 2 t to the negative 1/3 times 1/3 times 6, which is minus 2.
Would you cancel that?
So, yeah, so plus 2 t minus 3 minus 2 t minus 3 is 0. And then we have plus 6 minus 1/3 times 9, which is 3. And then we also have this plus 3 here that we can factor out. So that's also 0. And then we're left with negative 1/3 times t minus 3 squared. All right. Yeah. So, yeah, so I skipped. All right, guys, bring it back for a second. All right. So, I had to go over it one more time, so I kind of skipped this step. So I put this 3 in here since these are like terms. So I just factored out the 3 and put it in there. So it's 6 minus 1/3 times 9, which is 3. Okay, wait. I shouldn't do that. I'll just write it out again. I'll write in a different step. All right. So in our parentheses we have minus 0, 6 times negative 3 plus 9. 6 minus 1/3 times 9 is 3. So plus 3 plus 1/3 t minus 3 squared u to the t minus 3 plus 3 u to the t minus 3. All right, we good so far? So I have this negative. I'm going to distribute the negative. So that's minus 3 minus 1/3 t minus 3 squared u of t minus 3 plus 3 u of t minus 3. So now I can factor out this u t minus 3 and this t minus 3. So that leaves us with, okay, I'm erasing this. Almost there. We are almost there. So that leaves us with, I'm just going to write it all out again. F of t equals 2t minus 1/3 t squared u of t plus, I'm factoring out that t minus 3, so minus 3 minus 1/3 t minus 3 squared. Then we're adding that plus 3. U t minus 3. So this 3 and that 3 cancel out. I know that that's like a ton of algebra and it looks super gross and it is pretty gross, but that's just what's going to happen. And I accidentally made that plus 3 and that should be minus 3.
Shouldn't it also be a minus?
Yeah, this should be, yeah.
Shouldn't you also make it a plus?
Yeah, so this should be minus, and that should be plus. And then this should be plus. Alright? So, I have all the steps in my notes, so hopefully, like, if you read over the second time, it'll be more clear. So I'm just going to keep going. Does anyone have any questions? I know it's like a lot of algebra. I need to keep going. So this is going to be like our final. This is us just like making a piecewise function. So we're like not even close. No, we're kind of close. So plus 1/3 t minus 3 squared u to the t minus 3. All right, so now we have it in the correct form. We have a t squared, and a t. That's what we look to see. And then we have a t minus 3 and a t minus 3. So we are set. Now we just have to use the equation that's hidden, but it's over here also. So this is going to be on our formula sheet. So remember this. So we have the Laplace of this f of t, f of t equals e to the negative as. So here our a is 0, so e to the 0 is 1, so it doesn't matter. Of f of times the Laplace function of t. So for here we just have 2t, so that's 2, this one right here. So that's just going to be 2 over s squared minus 1/3. 2 factorial is 2 over s to the n plus 1, s cubed, and then plus, so e to the negative as, our a is 3, so that's e to the negative 3s times the Laplace of just our f of t. So our f of t here is 1/3 t squared, because we're not looking at that minus a. So 1/3 t squared, the same as this term, 2 over 3, 2 over 3 s cubed. So that is our final answer. Isn't that so delicious?
No.
So any questions about how, especially like I got this term to look like this? Guys? Yeah? This one? Hey guys, quiet up.
We chose to be here.
Say that again. Okay. So we have to have it, our formula says that we have to have it in the form f of t minus a, u to the t minus a. So since a is 3, we have to be in terms of t minus 3. But we can't just insert minus 3, because then that throws off the equation. So every place we have a minus 3, we also have to add 3. So here I did minus 3 plus 3, and then I just multiplied 2 by the 3 and brought it out and made it 6. Here I did the same thing, t minus 3 plus 3, and then when I FOILed it out, it left us with these terms instead. And so I had my t in terms of t minus 3 and t minus 3, and then this is just a constant. Does that make sense? So like here, right, it's t minus 0, so we don't have to do anything because this is still 0. Yeah, it has to matter what the u says. If the u is t minus a, then all the t terms have to be t minus a. Okay? Cool. Alright, so final answer right here. All right. Yeah. E to the negative 3s. So, because in our formula, it's e to the negative as. Right, so you have the formula out. So it's all right. It's late. It's getting late. Bring it back. We got two more things. These are a lot easier. That unit step was like super annoying. The inverse unit step is a lot easier. And those eigenfunctions we will breeze by and they will be so beautifully easy. Alright. So our inverse Laplace, right, if we see any function that's e to the negative whatever as, and it says take the inverse Laplace, we know it's going to be a unit step. So simple giveaway. So here's one example. So we have the inverse Laplace of 5 over s plus 1 plus e to the negative 2s over s minus 1 squared. Alright? So if we're just looking at this, right, we see, oh, this is super easy. That's e to the negative at times 5. Bam. Just using our table. Here we have e to the negative 2s. So what we're going to do is we're just going to ignore the e to the negative 2s for now. But we'll just make note that it's a unit step. So bam, unit step. But when we take the inverse Laplace, for the time being, we're not going to worry about it. So if we just break this up like we do our integrals and we just have, bring our constant out front and separate into two different terms. 5 times the inverse Laplace of 5 over s plus 1 plus, we're going to ignore this e to the negative 2s, inverse Laplace of 1 over s minus 1 squared. And we're just going to make another note. It's still a unit step though. Just so we don't forget.
First term is 1
over s plus 1, right?
You took out 5.
1. Alright. So now watch this, right? Alright, so this term, 5 e to the negative s, or e to the negative t, right? Easy. It's just this right here, 1 over s minus a. A is negative 1. 5 e to the negative t. Here, almost the same thing. We have a s term, that's s squared, but instead of s, we have s minus a. So it's going to be e to the at times f of t. if we look at our problem, it's s minus 1 squared. So n plus 1 equals 2, or n is 1. So it's going to be t times e to the at. A is 1. So when we put that all together, we get plus t to the 1 e to the 1t. So I'm just going to, that's just 1. So 5 e to the negative t plus t times e to the t. And again, we're not going to forget, this term is still a unit step. So we're almost finished. We have this term right here is going to come down because it's not a unit step. 5e to the negative t. And then we're going to go back to our e to the negative as. And we're just going to plug in, right, in our formula, e to the negative as. So we have f of t minus a, u to the t minus a. So we're just going to insert. It's just telling us that that term is t minus 2, e to the t minus 2, u of t minus 2. So everywhere we saw a t, we just plugged in negative 2 because it's e to the negative 2s. And then we added a u to the t minus 2 to the n. Super simple. Yeah. This? So this is just the same because it's not a unit step. And then here we have t e to the negative t, or t e to the t, and that comes from this term. This term we have an e to the negative 2s, so you know it's a unit step. So everywhere we see a t, we're just going to plug in t minus a, which is t minus 2, because that's what our formula over here says. Okay? This is the head. Yeah. So that first yeah. Because it's just this term by itself. So this term is not unit step. This term is unit step. Alright? Any other questions? Alright. Almost there. One last topic. And then you guys can go home and sleep. Alright. So this is our boundary value problem with our eigenvalue. So the purpose of this problem is to find what eigenvalues and what eigenfunctions will give us some type of real solution to the given equation. So we're going to have, the way we're going to set this up is we have like our ordinary differential equation. So we're going to use our auxiliary equation, m squared plus lambda minus 3 equals 0. And we're just going to set m squared equal to 3 minus lambda So added 3 and subtracted lambda on both sides. And then m equals plus or minus radical 3 minus lambda. So this is our first step. Super duper simple. And then we're just going to set up 3 cases and test each case and see if we can find an eigenvalue. So, case 1. We have 3 minus lambda is greater than 0. And we're just going to say mu cannot equal 0. So some people use alpha. I don't know if your professors use alpha or mu.
Yeah.
I need to use mu. It's the same thing. So we're just going to set mu squared equal to 3 minus lambda, right? So here we have 3 minus lambda. Here we have 3 minus lambda. We're going to plug mu squared right into there. So we have m equals plus and minus radical mu squared. And then so we're going to have 2m. So m1 equals mu, and m2 equals negative mu.
Wait, why are you doing mu squared?
Oh, it's same thing as alpha.
Same thing
No,
as
I know,
alpha
but
squared.
why is it squared?
So that's just like what the mathematicians say we do. So we say that mu squared equals this, and then we're just going to plug it into our, we're going to plug it into our auxiliary equation. Yeah. So we're going to keep going. Yeah, we just follow what the people say because they're smart. So we have y equals c1 e to the mu x plus c2 e to the negative mu x. Right? So this is just like what we did on the last test. c1 e to the m1x plus c2 e to the negative, or e to the m2x. So we're just, since they gave us initial conditions with our regular function and the derivative function, we're going to take the first derivative. So I'm just going to factor out a mu, c1 e to the mu x minus c2 e to the negative mu x. Okay, so multiplied by mu and multiplied by a negative mu here. So I just factored out the mu. C1 e to the mu x minus C2 e to the negative mu x. Okay. So, first, we're just going to do this first condition. So y at 0 equals 0. So we have y at 0 equals 0. So C1 e to the 0 plus C2 e to the 0 is just C1 plus C2. So C1 equals negative C2. Right? Super easy. These are just 1. So C1 plus C2 equals 0. Bam. Now, we're going to do the second condition. So y prime at pi equals 0 equals mu C1 e to the mu x, and then I'm just going to plug in, since C1 equals negative C2, I'm just going to say plus C1 e to the negative mu x equals 0. So, since we stated at the beginning, right, mu cannot equal 0, we know this term can't equal 0, therefore, so I'm going to also factor out this C1 first. So we have y prime at pi equals 0 equals, so I'm factoring out that C1. So mu C1 e to the mu x plus e to the negative mu x. So we're going to divide by mu C1, and we get 0 equals e to the mu x plus e to the negative mu x. So we can just say e to any power is always going to be positive. So it's going to be impossible for two positive numbers to add together to get 0. Do we see how that would be? So we can also just say, right, negative e to the mu x equals e to the negative mu x. This term is always going to be positive, and this term is always going to be positive. Therefore, if we negate a positive, this whole thing is going to be negative. So a negative cannot equal a positive. Therefore, we're going to say there's no solution.
Isn't it called like trivial?
Yeah, trivial, same thing. A trivial solution.
So do we not even have to incorporate like the pi? Like the y prime pi? Like, does it not
Yeah.
really matter?
I mean, it doesn't really matter. I probably should have done it. Pi. Pi. All right, so no solution. Now we're going to go to case 2. So in case 2, we're going to say 3 minus lambda equals 0. So we're going to do the same thing we did there with mu squared. So we just said mu squared, we're just going to plug that right into a radical. So we're going to do the same thing. M equals radical 0, which is just 0. So m1 equals m2 equals 0. So then our function is y equals c1 plus c2x. So right, so it's theoretically c1 e to the 0x, which is just 0, plus c2 e to the 0x times x. E to the 0 is 1, so just y equals c1 plus c2x. Going to take the derivative again. Y prime, so that's just going to equal c2. And it says that y prime at pi equals 0. So y prime, there's no x, so it's just going to equal 0. So c2 equals 0. So now we have y at 0 equals 0. c2 is 0, so we'll just cancel that out. So c1 also equals 0. So c1 equals c2. So we're going to have no solution again. No solution. So most of your problems are going to be this way, most likely. Don't quote me on that, but like case 1 and case 2 are probably going to be no solution. All right. So the last case, so this is where we're going to get our answer. Hey guys.
Guys!
Almost done.
Please.
10:35. Almost bedtime. So 3 minus lambda is going to be less than 0. Hey, come on guys. Almost done. One section, like not even a problem left. 1/3 of a problem left. We're going to say again, u cannot equal 0. So 3 minus lambda, we're just going to set equal to negative mu squared because that's what the mathematicians told us to do. And we're going to plug it into our equation. So m equals plus and minus radical negative mu squared. So here this negative is just going to give us an I term. So we're going to have m1 and m2 equals plus and minus mu I respectively to m1 and m2. So our beta term, our beta is going to equal mu. So when we solve this equation, we have y equals c1 cosine mu x plus c2 sine of mu x. All right. So we're going to plug in that initial condition, y at 0 equals 0. Y 0 equals 0. So c1 cosine 0 is 1. So that equals c1 C2 sine of 0, sine of 0 is 0, plus 0 is 0, so C1 equals 0. So cross all that out. So now we're just going to take y prime, just of x. So we're just looking at this term because C1 is 0. So that's mu C2 cosine mu x. And we said mu prime at pi equals 0 equals mu C2 cosine mu x. So we're going to divide both sides by mu C2. So cancel, that cancels, 0 divided by whatever, 0. So we have 0 equals cosine mu of x. So now there are possible things we can plug in for mu that would give us 0. So this is probably just something that you're going to have to remember. So pi, so this x is mu. Pi, sorry, thank you. So pi mu equals 2n plus 1 over 2, and n equals 1, 2, equals any integer. So anytime that this term equals 2n plus 1 over 2, there's a pi here also. So anytime pi mu equals 2n plus 1 over 2 pi, then this cosine term is going to be 0. So if you think about it, right, so when n is 1, it's going to be 2n plus 1 over 2. So that's 3 over 2 pi. So like on our unit circle, that's going to be right there. And that's going to give us 0. And then if we plug in 0, it's going to be pi over 2. So that's right there. So cosine is 0 there. If we do anything else, right, it's just going to land on these two spots with any integer. So we have almost done. So we have these pi's are going to cancel. Mu equals 2n plus 1 over 2. And we said that negative mu squared equals 3 minus lambda. Yes?
Is it added 2 and minus 1?
It's the same thing.
Okay.
Yeah. So plug it in there. We have, I'm just going to bring this board down for a second. Oh, there's writing on there. Okay, I'm just going to write it here. All right, almost done, guys. 3 minus lambda equals negative 2n plus 1 over 2 squared. We're going to add this to the left side, add the lambda to the other side. So 3 plus 2n plus 1 over 2 squared equals our lambda. And our n equals 0, 1, 2, 3, blah, 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 any integer. And then we're going to plug our lambda into our, where is it? Right here. Or plug our mu into here. And we're going to get our y equals c times sine 2n plus 1 over 1 pi x. No pi.
Can it also be over 2?
Over 2. And x. Alright, so this is our eigenvalue, and this is our eigenfunction. They might just ask for one or the other, but that's what they are. Yeah.
If it was a sine u pi, would that like 2n plus 1 over 2 be different?
Yeah, so if it was sine, so if 0 equals sine mu x, then it's going to be mu x equals just any integer over 2 pi. All right. Any other questions before you guys go? Yeah.
Like, why is it not this function?
In here, because it's just mu x. So we just plug. Yeah,
Oh
we
wait,
just
no,
plug yeah, but that's not enough. All right, thank you guys. Let me know if you have questions. Email me. Fill out my form so I can send you my notes.